Incident profiling. In dealing with incidents, it is important to diagnose and resolve the cause, but profiling of attacker and incident is becoming important in order to establish a preemptive defense strategy. In this course, we will look at how to profile an incident. Let's look at profiling and its methods and see how it can be applied to incidents. First, let's review what profiling is. The term profiling is defined in a variety of fields, including crime psychology and computer programming. The concept of profiling that is discussed here is that of criminal psychology, and it surpasses a particular individual's profile to express the incident deduction. Profiling in IT audit, incident response, and compliance is gaining importance because of the generalization of technology advancement and anti-forensic techniques. In the past, it was relatively easy to deduce an incident only by the traces that were revealed, but in recent years, the traces themselves are often hidden or deleted, making profiling more difficult. Therefore, it is necessary to systematically manage the trace along with the enhancement of analytical techniques so as to predict the occurrence of the accident in advance or deduce the influence of the accident. Let's look at the profiling techniques needed in the incident response field. The traces of the system left behind by the user's actions are called forensic artifacts. Forensic analysis is the reconstruction of user behavior through these forensic artifacts. Forensic artifacts can be roughly classified into two types. The first is data that is programmed to generate B when A occurs, such as a log. In this case, A can be deduced through B. The second is a B trail that is left while processing A when A occurs, and this trace can consist of more than one. Examples of this include traces of copying files to a storage medium, traces of program execution, and the like. In this case, to infer A through B, B must be the only trail generated through A. In other words, if there is a possibility of B coming out through A, the accuracy of reasoning will be lowered. The good news is that a lot of analysts have already done a lot of research on the relevance of the second forensic artifact. We need to think about how to manage and reason for known forensic artifacts. In order to perform profiling, data must be accumulated first. You must first define the goals you want to achieve with profiling. Then define the collection method and retention period for the required data. The more data you have, the better, but the more data you do not have, the more you will need to accumulate since this will hinder profiling. The accumulated data must be processed in various forms to enable profiling. The processing method can be defined in advance, but since it can derive new meaning from the data, it is necessary to create a framework to allow it to be changed at any time. Using visualization can also be effective in deriving meaning. In the incident response field, the data accumulation can be divided into image files and logical data, which are copies of the storage media. Since the copy image file is large in size and contains a lot of unnecessary data, it is usually stored in the database based on logical data or extracted from the logical data by only extracting elements necessary for incident response. When the range of data is determined, it is processed into proper form and converted into a database. NoSQL is used commonly nowadays. Database data must be able to expressed in a structured form. Widely used formats include OpenIOC, STIX, and SIBOX. When unnecessary data is accumulated, it is expensive to manage it, so you only have to accumulate the necessary data. It is important to understand the type of incident and try to accumulate only valid data. Forensic semantics related to user behavior can be extracted from accumulated data and classified by each type of accident. The advantage of forensic analysis is that the type of data is not significantly different depending on the type of thinking. Since the meaning of the same data varies from one viewpoint to another, we have to focus more on data representation than data accumulation. The data expressed by the type of incident should be converted into database to enable association analysis. By accumulating database data continuously, it is possible to derive common features or unique features of incidents. These derived features can be used to detect or monitor incidents in advance. We have looked at the basic concepts of profiling. Let's now look at how to use profiling in the incident response field. The forensic artifacts that can identify infringements or infections in the incident response field are called indicators of compromised (IOC). The profiling of incident response focuses on how to create and manage IOCs. Traditional IOCs in the field of accident response include IP, domain, and malware hash. However, it is difficult to profile recent incidents with traditional IOCs, as fileless malware with no recent files is used. Files are deleted with anti-forensics, and fast flux and domain shadowing technologies become common. To overcome the limitations of traditional IOCs, it is necessary to manage forensic IOCs. Forensic IOC means the trail left by an attacker's actions. In analyzing the traces of incidents, systematic analysis according to attacking stage of the attacker and management of traces can overcome the limit of conventional IOC. Malicious code enters the internal network and flows through the process of inflow, execution, continuation, and spreading until it reaches its final destination. Each technique leaves a unique trail according to the technique used. Managing these traces as an indicator helps to identify incidents more quickly and accurately. The following is an example of a forensic IOC extracted through system analysis. Trace is traceable even if there is no file data from the cause of the inflow to the action after execution. It is easy to delete files from the attacker's point of view, but it is almost impossible to delete all the data left behind by the action. If you manage the indicator systematically and quickly respond, you can identify incidents relatively easily. Let's look at the benefits of forensic IOC management. First, it can overcome the limit of traditional IOC because it focuses on user behavior. Second, by diagnosing a suspicious system as a forensic IOC, as in the case of an antivirus diagnosis, the pre-detection rate of the incident can be increased. Third, by using forensic IOCs extracted from systems where infringement has been identified, additional infectious systems not identified can be discovered. Traditional detection methods are difficult if the malicious code is not currently running, but using forensic IOC can diagnose the behavior in the system. Fourth, because the forensic IOC is based on the attacker's actions, it can be effectively used to identify the causes and processes of the incident. Finally, because of the way hacking is reflected or faded, if forensic IOCs accumulate, they can be used to identify characteristics of attacking organizations that are currently targeting our organization, or to identify similar organizations and malicious codes. Although the benefits of forensic IOC management vary, there is a hurdle to overcome. First, the anti-forensic technique is advanced and the trail that is used for the creation of the forensic IOC is also deleted, so the forensic technique needs to be advanced. Secondly, there is very little data available for basic host system configuration alone. Therefore, it is necessary to strengthen the security configuration of the host system and to strengthen the artifacts that can be used for incident analysis. Finally, in addition to efforts to identify incidents, identification procedures are very important. Because the initial response procedure can affect the overall incident analysis, it should be done quickly without compromising the forensic IOC. The host-based forensic IOC information we have seen so far can be used as system intelligence information through accumulation. System intelligence information should be combined with previously managed network intelligence information and external OSINT information to provide analysts with a new perspective.